Hi everyone, welcome to the third person lock-on camera video documentation. Today we're going to be going over a few simple steps to get this camera set up in your game. After that, we're going to be going over some customizable features and then some frequently asked questions. Let's get started. The first step is to remove any camera objects you currently have in the hierarchy. After that, go to your prefabs folder and drag and drop the camera rig prefab into your hierarchy. From here, select the game object that you would like the camera to follow. For me, this is a third-person controller. And change the tag from untagged to player. After that, the next step involves whether or not you have a canvas object. If you don't have a canvas object, like I do not here, drag and drop the cursor canvas from the prefabs folder into your hierarchy. If you do have a canvas object, instead of drag and dropping the cursor canvas, drag and drop the Z-Lock cursor prefab under the canvas as a child object. The next step is to add the object lock-on script to any of your game objects you would like to lock onto. For me, this is enemy 1, 2, 3, and 4. To do this, go to your scripts folder and drag and drop the object lock-on script to each of your enemies. Now this is made easier once you've created a prefab for your enemy that already contains your object lock-on script. The last step is to change the camera input in the input manager. Now this step is optional, but it is highly recommended. By default, the camera uses the mouse X and mouse Y as inputs, and fire 3 to lock onto enemies. But it's recommended to add 3 new inputs, called camera X, camera Y, and Z-Lock, so that way you can set those inputs to whatever is best for your game. Once you've created these 3 inputs, the camera will no longer use the default values of mouse X, mouse Y, and fire 3, but instead will use the values camera X, camera Y, and Z-Lock. And that's it. That's all you need to get your camera up and running in your game. If you do notice any problems, such as the cursor icon not being in the center of your game object, or your camera not being at the right position, listen on to the customization section. If you'd like to adjust the camera's position or rotation, start by copying the position of the player object your camera is following. This can be done by copying and pasting the position X, Y's, and Z values into your camera rig, or a little bit more easily by copying your player object's component for its transform and pasting it into the transform of your camera rig. From here, make sure that your rotation values are all 0 and your scale values are all 1. Now that your camera rig has the same position as your player, we can hit play and look at what the camera looks like. Now if we would like to adjust the position of the camera, instead of adjusting the camera rig's position, we want to adjust the child object called pivot. Any adjustment done to the camera rig's position will not persist once we hit the play button, but any adjustment done to the pivot's position will persist after we hit the play button. So as an example, if we want to move the camera, let's say 4 units to the right, this will persist when we hit play. And as you can see, the camera is 4 units to the right. If you would like to adjust the rotation of the camera, the component that you'll have to change varies depending on which axis you're trying to rotate around. So if you're trying to rotate the camera left and right around the Y axis, you want to go to the camera rig's Y rotation. By changing this value, we can start what the default value's rotation is. So if we start playing now, we can see the camera is facing behind our player. But if we change the camera rig's Y value here to, let's say, 180, and we hit play, we can see now that the camera is facing the player. If instead we'd like to rotate around the X axis, meaning moving the camera up and down, we want to change the pivot's X rotation. So if we look at the camera now, we can see that the camera is facing slightly downwards. But if we want the camera to face exactly level, we can change the rotation to 0 on the pivot, and we can see now that it is perfectly behind our player. That's how to customize the camera's default rotation and position. Now let's go over what each of these customizable features does on the camera lock-on script. Rotation speed controls how fast the camera rotates around the player, also known commonly as the camera sensitivity. A higher number means the camera will move faster around the player, and a lower number means the camera moves slower around the player. Camera move time controls how fast the camera follows the player as the player is moving. A higher value means that the camera will follow the player more slowly, so the player won't always be at the center of the screen. A lower value means that the camera will follow the player more tightly, so the player will always be towards the center. Minimum Y rotation is the minimum angle the camera will rotate downwards. Similarly, the maximum Y rotation is the maximum angle the camera will rotate upwards. Lock-on looseness controls how tightly the camera will follow the enemy when locked onto them. A lower value will keep the enemy more towards the center of the screen. A higher value will let the enemy wander to the sides of the screen. If you notice that your camera is jittering while locked onto an enemy, try raising the looseness value here to prevent the jittering. Z-lock distance controls the maximum value that an enemy will be able to be locked onto. In this case, any enemy greater than 25 units away from the camera will not be able to be locked onto. Z-unlock distance controls the maximum value that an enemy will be able to remain locked onto. In this case, if an enemy is already locked onto and they become greater than 30 units away from the camera will automatically unlock from them. Please note that the Z-lock distance must always be less than or equal to the Z-unlock distance. And those are all the customizable features in the camera lock-on script. Next, we're going to take a look at all the customizable features in the object lock-on script. The first customizable feature is a list called layer names. Every game object has a layer field found underneath the game object name. Any layers written in this list has the capability of blocking enemies from being locked onto. By default, the layer terrain will prevent any enemy from being locked onto if it's between the camera and the enemy. To put it simply, if you can't see the enemy because the game object with the layer terrain is blocking your way, you won't be able to lock onto them. When you're locked onto an enemy, the lock-on cursor icon will appear where the game object's origin is. Now ideally this is at the center of the game object, but sometimes it occurs that the origin will happen at the base of the object. So the X cursor change will allow you to change where the lock-on cursor shows up on your screen in relation to its X-axis. The Y cursor change is similar. This allows you to change the Y location of the cursor lock-on. Now that's everything for the object lock-on script. Now let's look into a few more customizable features and some frequently asked questions. If you'd like to change the lock-on cursor icon, go to the Z-lock cursor game object, which can be found under the cursor canvas if you use this prefab. From here, simply go to the image component and change the source image to any image that you want for the cursor lock icon. Notice that the image component is not currently active, as it's only active when you're currently locked onto an enemy. So there's no need to activate this component manually. Now lastly, if you want to know if your camera is currently locked onto an enemy, or if you would like to know which enemy your camera is currently locked onto, you can call one of these two public functions, isZlocked or getEnemyTransform. And that should be everything you need to customize your camera and have it running in your game. Thank you very much and enjoy.